Saxon's Trig, Lesson 70, Percentiles and Z-Scores, is a lesson that I choose to skip every year, so you will not have a video about it. So this will actually be Lesson 71, which is the ellipse part 1, and it's beginning on page 445. So we've talked before about the fact that when we have a cone and you slice the plane straight, you're creating the circle shape. And the ellipse is when you are cutting through at an angle, forming more of a squished circle. And so that's what we're going to talk about in this lesson. So there are actually two focus points, and I'll come back to that on the next page. But at the bottom of page 445, it has some bolded words. Each of the points is called a focus point, and I said there will be two of them for this, of the ellipse. And collectively, the points are called the foci of the ellipse. So let me just go ahead and do it here, even though it's pictured on the next page. If you have two focus points and you picture a string between them, the ellipse, the squished circle, is what you get as you rotate that string around. Because as you come here, it's going to be stretched at its thinnest point. And the other places, it's going to be a little bit looser, therefore you can go wider away from the focus points. So the locus, the equidistant of stretching this string, so it's equally distant from the focus points by the distance of that string. So that's what they're trying to tell you there. The ellipse is the focus of points such that the sum of the distances from a point on the ellipse to the two foci is a constant. So hopefully their wording and my my picture is enough to help you understand their wording there. On page 446, you can see it very clearly demonstrated in all of their examples. And then at the bottom of the page, they talk about this long distance, the longer distance across going through the two foci points is a major axis. And it can be horizontal or vertical. So horizontal would mean it's looking this way. Vertical would mean it's coming straight up and down. And then if you go the shorter distance across, that one is the minor axis. And it shows you both of those pictures where they're kind of inclined, they're slanted. They can be horizontal or vertical, so they're just showing you the different ways that you can write it. Now at the very bottom of the page, they give you the standard form for the ellipse. So just like a circle, it's based on an x squared and a y squared. The numbers should be matching here and here as well, but the new part is there is a fraction created and there's numbers underneath the x squared and the y squared, and they call them a squared and b squared, and the problem always equals 1. So our general form usually equals 0. This one you're going to tell because it's going to be in a fraction format and it's going to equal 1 as opposed to non-fractional and equaling the radius squared for the circle. In their other equation, they flipped it and said this one's b squared, this one's a squared. It doesn't really matter which way is which. They were trying to make a distinction between if this one is the larger number, then this is the major axis, and the y value going vertically would be the minor one, is all they're trying to say. So let's see, standard form. Yes, the letter A is always associated with the major axis, which I just told you. And the smaller one will be the minor axis. All right, and then the other thing I didn't tell you is that all of the two longest pieces out, the end of the horizontal axis and the ends of the vertical axis, they are your vertices for the ellipse, the main points for the ellipse. All right, so in example 1, it tells us x squared over 25 plus y squared over 9 equals 1. And it wants it graphed. The graph is super simple, unlike the parabola, which is a little bit more work. So on the x-axis, we are going to take the square root of this number. So the square root of 25 is 5. and go 5 on the x-axis. And those will be 2 of the vertices. The square root of the 9 will tell us to move 3 on the y-axis, and that's the other 2 vertices. And then we draw, oops, missed just a little bit, we draw the ellipse. Super simple to graph it. Example 2. Write the equation in standard form, so that tells me it's not quite there, and graph. All right, so this time it's giving me 5x squared plus 2y squared equals 15. Now you're going to argue this doesn't look like an ellipse because it's got different numbers here with the x squared and y squared. That may be true, but it also doesn't equal 1, so it's not in its standard format. So the first thing is to divide everything by 15 in order to get this equaling to 1. So x squared over, and then 5 and 15 reduce to 1/3 plus, and then this 2 over 15, oh, they put it in decimal. It does not reduce beautifully. So since it's 2/15 y squared, if I need to write it underneath, I'm going to flip the fraction as I write it underneath. So this actually becomes 15 over 2 if you want to put it in fraction. They put it as 7.5. Either way, problem equals 1. Now we've put it in standard form. Next thing they ask is for the graph. So we are going to be going, square root of 3. I'm going to have to do on my calculator to get some sort of approximate. It's 1 point something, and I'm looking here and it says 1.73. So I'm going to estimate about here and here, but I am going to label that, whereas before it wasn't an estimate. So I'm going to label this as root 3. As long as I label one of them, you would imply that it's the same the other direction because it's going to be an ellipse. And obviously 15 over 2 square rooted, even doing it in its fraction form doesn't give me nice numbers. So just do the square root of 7.5, and that's going to give you 2 point something. So 2 point something, both of these directions. And because this 2 point something is actually bigger, it is your major axis. I'm gonna go ahead and see, it looked more like a circle the way I drew it. I spaced the x's more than I spaced the y's. That's why it looked more like a circle than an ellipse. But then I would most definitely label this the square root of 15 over 2, or the square root of 7.5, however you wish to label it. You've got your graph there.